Alrighty, so what we're going to talk about are resistance in series and parallel circuits. We're going to talk about the voltage and we're going to talk about the current, which are all things that you're going to have to do in, I think, both of the assignments for week 3. And then don't forget, next week we're going to do a review, so yay, Jeopardy. Hey, Logan. Brandon. Okay, ready, set, go. Maybe. There we go. Our learning objectives. So at the end of this lesson, you're going to be able to calculate combined resistance of 2 or more resistors in a series. And then you're going to calculate the resistance of 2 or 3 resistors in a parallel circuit. So there's 2 kinds of circuits. What are they? What are the 2 kinds of circuits?
Single and parallel?
Series and parallel. Good. Keep typing. What's the other one? Thank you, Gabby. Series and parallel. And the ladies over here did tell me that also. So, whoops, go back. There we go. They're series and parallel circuits. So, resistor arrangements. Now, this is important. Okay, when they're in a series, that means they're one right after the other. Let's put our phone upside down on the table. I know. That just sucks, doesn't it? Okay, so when they're in a series, they're one right after another. And when they're parallel, they're like on top of each other, kind of like rungs on a ladder or steps on a ladder, whichever way you want to call it. Okay, so look at your circuits before you decide what you want to do with them. So when you have resistors that are in series, the total resistance here is going to be when you add them all up. So R1 plus R2 plus R3. That's going to be the total resistance. Okay? That's different from parallel. Because in parallel, what you have are things, you're going to add them up. Let me see, hopefully, yeah, good. Like this. So for this one, you're going to need a calculator. So whatever resistance 1 is, it's 1 over that. And then 1 over 2, and then 1 over 3. Now, I'm going to show you a shortcut that works for just 2 resistors in parallel. Okay, so for just 2 resistors, if you only had 1 and 2 here, then what you could do is that you could say the total resistance of 1 and 2, and I forgot my pen again, so. Say again? Okay. Is going to be the product, or you're going to multiply these together, and then you're going to divide by the sum. Does that make sense? Okay, stop it. I have no idea what that is. Hold on, I'm trying. Okay, so that's only if you have 2. If you have 3, you could do 2 and then whatever that total was with the other one. Does that make sense?
Wait, it only works for 2, right?
Well, it would work for 3, but you would have to do 2 first.
Oh, and then add the third one.
And then, like, you would get your total resistance here. Say it's, I don't know, 5. Then you would do the same thing for this 5 and whatever 3 was. Okay? Or you can always do this. And again, just when you do that, you'll need a calculator. Unless you want to do it by hand. Calculators are easier. Okay, so does that make sense? In parallel, it's 1 over the resistance is equal to 1 over the total. And in series, you just add them up, one right after another. Okay, so if two resistors, R1 and R2, are connected in parallel, then the total resistance is going to be smaller than either one of them individually. Does that make sense? So if R1 is 10 and R2 is 20, your total resistance is going to be 20 divided by 3, which is what? Quick.
Like 6 point something.
Okay, sure.
Something like that.
Sure, that was close. Anyway, it's less than 10, okay? It's going to be less than the smallest one. Does that make sense? Okay, it's because it's the reciprocal. It's because it's like the denominator of a fraction. All right, see, and this again is like what I tried to show you, what I tried to write, but couldn't really very well, right there. If you only have 2 of them, you can multiply them together and divide by the sum, or whatever it is that you add together. Make sense? Make sense over there, guys? Hello? Okay, good. All right, so resistors in series, you add them up. Resistance in parallel, you also add them up, but you add up the reciprocals. Now we're going to talk about current. Okay, so by the end of this lesson, you're going to be able to understand the current at every point in a series circuit is that's always going to be the same. So if you start out with 3 amps, through the entire circuit, you're going to get 3 amps. But in parallel, if you start out with 3 amps, it's going to divide up into each one of those branches. All right, so each branch is going to have less than 3. But when you add up the current across each branch, it's going to add up to 3. Okay? Easy stuff, right? So the reason that in a series circuit you have the same current throughout is because there's only one path for it to follow. Okay? It can only go this way or this way, depending on the battery, really is whichever way it goes. Okay, so there's only one path, so in a series circuit, the current is always the same. So the current across this resistor is the same as the current across this resistor, and it's the same as that one. Everywhere it's the same. So what will happen if one of these lamps is being removed in this circuit? If I take out one of these light bulbs or one of these light bulbs go out, what happens to the other ones? Anybody?
Would there be less resistance?
There would be less resistance. However, if I took out this, so let's just say I'm going to take out this light bulb. It's gone. The current is going this way, and it comes across this light bulb. What happens? It can't go anywhere because this light bulb is gone. Okay? You can't hear me. Can you hear me now, Gabby? Hello? Okay. I don't know how to make it any louder. All right, so in a series circuit, if any one of these light bulbs go out, the whole thing goes out. Okay? That's kind of like, hopefully, it's like your, well, not hopefully, but it's kind of like what Christmas tree lights do. If one of them goes out, they all go out. Because it breaks the circuit. That means that it's like, it's not a closed loop. If you remember at the very beginning, we talked about closed loops. All right, so what about the lighting in your house? Do you think it's connected in a series? So if one light bulb goes out in your house, does all of them go out? No. So that means that it's not a series, your house is wired in
Parallel.
parallel. Okay? All right. And why do you think it's wired in parallel?
Because if one light bulb goes out, like the rest shouldn't.
Yeah. If the light bulb in your bedroom goes out, you know, why in the world would that make a difference to the kitchen? But if it were in series, it would make a difference. Okay. So the difference here is that hold on. Okay. In parallel, what happens to your current is, I think it's going this way. It's going to come in here and then it's going to branch out 3 ways. Okay? So that would mean that it can still go this way, right? You're still going to have a current here, or here, or here. So the current branches out. It has more than one path to follow. All right? So all of these little currents, current 1, 2, and 3, should add up to the total current in that circuit. All right. So what would happen if one of these lights were removed? If you didn't have this light anymore, what would happen to the rest of them?
So they would just still turn on.
They would still turn on because they still have current, right? This one would be burnt out because now this is like an open, it's not a closed circuit, it's not a closed loop, but the other 2 still are. So you still have things that are going to go. So in this figure, A, B, a copper wire. Okay, that must have been the other one. Let me go back. Never mind. So, excuse me. Some copper wires have very little resistance. I don't know if you can read that anymore. Let's go back. So, if you have very little resistance, then a large amount of current is going to go through there. If a large amount of current goes through there, then the light bulb will go off. Do you guys remember from, I don't know, first week when we talked about light bulbs and the fact that they had the little filament in there? Okay, they have like their own type of fuse that sort of saves the house from burning down. That's why the light bulb goes out. You couldn't possibly be doing that about my.
No, I'm not doing that because you're and I don't have my phone either.
I know, you're watching something else. Okay, so then we say it's a short circuit. That was weird that it all came up wrong. So in a series circuit, there's only one path for the current to flow, and that means that if something goes out, it all goes out because it doesn't short circuit, it opens the loop. And then in a parallel, there's more than one path for the current to flow, so one of them can go out and the others can still stay lit. And the current is different in each part of those loops. All right, so the last thing we're going to talk about is voltage in series and in parallel. So at the end of this, you're going to know that in a series circuit, the voltage or the potential drop across each resistor is going to be different. And we're going to use the potential drop across the components in a parallel circuit is always going to be the same. So in a parallel circuit, the voltage is always going to be whatever it starts out to be. If you have a battery that has 24 volts, it's going to be 24 volts through the whole circuit in a parallel circuit. And in a series circuit, if you have 24 volts, then across each resistor, it's going to be different. But when you add up all the voltages across a series circuit, it should add up to the total voltage, okay? So it doesn't matter how many resistors you have, whatever you have going across each one should add up to whatever you start with, whatever the battery or whatever is generating that voltage, okay? Easy stuff. But I will tell you guys that next week, I know obviously we're going to have another webinar and it's going to be a game, but that's going to be your summative exam. And all of this stuff is going to be on there. Okay?
Wait, that game is going to be our summative exam?
No, there'll be a summative exam after. The game is sort of like a review.
Oh.
So if you don't want to do, you can look at it if you want, but if you don't want to actually do the exam until Friday, that's fine. But if you feel ready before then, go ahead. Okay, so this right here is pretty important. And if you guys have notes that you take whenever you're doing this stuff, you can use those on the exams. Okay, I don't have a problem with that at all. So in parallel, whatever you have here is equal to here is equal to here. The voltage is the same across all of them. Okay? But the current is going to be different, right, in this parallel, but the voltage is going to be the same. So the PD stands for potential drop. Across all the components in a parallel circuit is the same. And across the series circuit, it's going to be different, but they're all going to add up to whatever you start with. Okay. So let's, I think this is a problem. I can't remember. In the series circuit, we only have one path to follow with the current, and then the sum of all, this is just, little notes. I can't remember if I put a problem in here. Parallel circuit has more than one path for the current to flow through it, so I1 plus I2 plus I3 is equal to the total current, and the potential drop is the same, so all of that. There we go. This is my example. So we have, first off, what kind of circuit is this? Excuse me. It is a series. So what is the combined resistance? What is the total resistance here? 6. Yep, it is 6. That's all you do is add those up. Piece of cake. Oh, yeah, 6 plus 2 is 8. Thank you. I'm a math teacher. Okay, so the combined resistance is 8. It's 6 plus 2, right? What is the current that's flowing through here? We have our voltage up here is 4. Okay, so what's the current?
Wait.
Let me, one thing you guys, and however you want to remember it, I don't care. But this is kind of helpful if you like pictures. So if you have voltage up here and then resistance or current, I'm sorry, over here and resistance. Okay, so we want the current. So what we do is cover up our current. That's what we're looking for. So it's our voltage divided by resistance. Make sense? So it's 4 divided by 8. So what is our current? 0.5. Excellent. And so what is the potential drop across the 6 ohm resistor? So that would mean that we're looking for the voltage, right? What's our current? What's our resistance? No, just across the 6.
Oh,
6. So 0.5 times 6 is, what's half of 6? 3. So that's the voltage across here. Real quick, the voltage across 4 divided by 2 is 2. So 3 plus 2. That's got to be 4. I did that wrong. I did something wrong. I can't think.
What is potential drop?
Potential drop is just the voltage across a resistor.
Just
So one resistor. If you start out with like 24 volts, then you have, and across for the first resistor, if you have a potential drop of 6, that means you're going to take away 6 from that 24. Okay? All right. So we got 0.5 and then 0.5 times 6, and we got 3. All right, we'll just do a quick one in parallel. Combined resistance. If we have 2 in parallel, then all we do is multiply and divide, right? So it's going to be 6 times 3 divided by 6 plus 3 is 9. So 18 divided by 9 is 2. So that's our combined resistance, our total resistance. Okay? Easy when you just have 2. All right. So the current flowing in the main circuit. So what is the current flowing through the main circuit here? Again, remember V is equal to IR. If we want the current, we know that the resistance is 2. The voltage is 12. 12 divided by 2. Anybody?
What?
What's 12 divided by 2? 6. Okay? So that's the total current through the whole thing. And then the current through the 3 ohm resistor is what?
Wait, can you repeat that one more time?
The last question? Just the current through the 3 ohm resistor. So the current that's going through this top one.
It would be 12 divided by 3.
Oh, that's, yep, it's going to be 4. And that's it. So that they're pretty easy to do, right? There's not a whole lot to do. We're not going to do this one.
And then for the total current on the other one, you just add the 2 amps together.
Yes, exactly.
For the amount of amps.
Mm-hmm.
Okay.
Perfect. Okay, so this last example is, there isn't a problem like this. This is just sort of like for challenge, anybody that wants a challenge. All right, we have in series and in parallel. You do the parallel first, and then you do series to find the total resistance. Okay, parallel first, and then the parallel plus the other one in series. So total we have 20 ohms for our resistance. The next question is, what's the current flowing through the 8 resistor? So right here, it's just 16 is equal to 20 times the current, so it's 0.8. And the reason that it's 0.8 is because whatever the current is here, remember there's no other place for it to go. Okay? That's it. All right, so you guys remember, next week is review and your summative exam. Anybody have questions? If you have no questions, thank you so much for coming so I don't have to talk to myself, even though I kind of feel like I talk to myself.
I listened to you.
Okay.
I just didn't talk back.
All right. Well, good you didn't talk back.
Yeah.
Okay, so if you have no questions, guys, we're done.
Oh, I'm so sorry.
That's okay. I don't think these guys